Hey everyone, welcome back. In our 66th episode, we ran into a really bizarre problem. We clearly cleared out the database, but our users were still seeing the old data. What was going on? It turns out, this is a classic case of a dirty cache being worse than no cache at all. Today, let's dive deep into the world of caching. So, what exactly is a cache? And what do we mean by cache consistency? To understand this, let's use a simple analogy. Imagine a large warehouse, which is our database. It holds everything, but finding a specific item can be slow. Now, imagine a small, quick pickup window at the front of the warehouse. This window, our cache, keeps a small selection of popular items ready for immediate pickup. It's super fast, right? But what happens if the items in the warehouse change? Let's say a product gets updated, but the quick pickup window still displays the old version. A customer comes, grabs the item from the window, and gets outdated information. This is what we call a dirty cache or data inconsistency. The data in our fast lane, the cache, doesn't match the source of truth, the database. To prevent this, the warehouse needs a system to notify the pickup window whenever an item is updated. This notification is called cache invalidation. The moment the warehouse stock changes, a message is sent telling the window, "Hey, this item is old. Get rid of it and fetch the new one next time someone asks." This ensures customers always get the latest product. There are different ways to handle this. One strategy is to simply remove the old item from the window. The next person who asks for it will have to wait a bit longer as the clerk runs to the warehouse to get the fresh version, but at least they get the right one. Another approach is to immediately update the item at the window as soon as the warehouse stock changes. This is faster for the customer, but puts more work on the warehouse staff to keep the window constantly synced. Now, let's talk about some common problems that can mess up this system. What if someone keeps asking for an item that doesn't exist? Imagine a prankster repeatedly going to the pickup window and asking for product XYZ, which has never been in the warehouse. Each time, the clerk at the window says, "I don't have that," then runs to the back, searches the entire warehouse, and comes back empty-handed. This is a huge waste of time and resources. In the tech world, we call this cache penetration. The prankster is bypassing the cache and hitting the database directly with requests for non-existent data. This can slow down or even crash our entire system. To stop this, we can get clever. When the clerk finds out product XYZ doesn't exist, they can put a note at the window that says, "Product XYZ does not exist." The next time the prankster comes, the clerk just points to the note without having to go to the warehouse. This is like catching a null value. It blocks the malicious requests at the front gate. Another scary scenario is a cache avalanche. Imagine the quick pickup window suddenly closes for maintenance. Maybe its power goes out. All at once, every single customer who would normally use the fast window rushes to the main warehouse entrance. The warehouse gets overwhelmed by the sudden flood of requests and grinds to a halt. This is what happens when a cache fails. All the traffic that was being handled by the cache suddenly hits the database simultaneously, potentially causing it to crash. To prevent this, we need safeguards. We could use a queuing system, like forming a single file line to control the flow of requests to the database. Or we could have a backup power source, a secondary cache to take over if the main one fails. These high availability solutions ensure that even if one part of our system goes down, the whole operation doesn't collapse. So the core trade-off with caching is always speed versus the risk of stale data. A cache gives us incredible performance gains, making our applications feel snappy and responsive. But if we don't manage it properly, we end up with logical errors and a terrible user experience. Think about an e-commerce site. If a product's price is updated in the database, but the old price is stuck in the cache, a customer might buy it at the wrong price. That's a serious business problem. The key is to have a clear and reliable update path. Every time data changes in the database, there must be a bulletproof mechanism to either update or invalidate the corresponding data in the cache. Any break in this communication chain leads to inconsistency. And this brings us to a much bigger topic, which is the security implications of all these moving parts. We have our data, our application interfaces, and maybe even message queues that trigger cache updates. All these components are constantly communicating. If the permissions and access controls between them are a mess, our system doesn't just become unreliable, it becomes a security minefield. An attacker could potentially manipulate the cache to show false information or bypass security checks that are supposed to happen at the database level. We'll explore this security minefield in our next video. We'll look at how poorly configured permissions can create vulnerabilities and how to properly secure the interactions between your database, cache, and application logic. It's a critical topic that every developer needs to understand. Thanks for watching today's deep dive into caching. I hope this metaphor of the warehouse and the quick pickup window helped clarify these concepts. If you found this useful, don't forget to hit the like button, subscribe, and ring that bell so you don't miss our next episode on system security. See you then.